An Introduction to the Windows of Laser and Optical Simulation Software LASCAD. Part 1. By Amin Hosseini, Laser Engineer and LASCAD Sales Manager. Multiple LASCAD windows in one frame. The first window after double-clicking on LASCAD 3.6.6 icon. You have to open a new project according to your target in simulation. Number of elements and output beam wavelength are your early considerations in this window. You can also open some LASCAD default examples by clicking on the File tab. We have three windows as an optical workbench and graphical user interface. There is a main menu window which you can open the FEA, DMA, and BPM codes and watch the results. The middle window shows our cavity mode plot in X and Y directions with all the elements we introduced for our laser. The lower window is parameter field 1, which you can change parameters such as mirror, dielectric interface, lens, refractive index, apertures, beam quality, and also distances and angles. In the FEA code running, you should determine your kind of simulation in this window firstly. LASCAD as a virtual lab presents common diode pumping such as end or side pumping in rod and slab crystals, as well as uncommon diode and lamp pumpings which let you use software such as Zemax and TracePro for importing data results to LASCAD. According to the chosen configuration we can define length, diameter, and our crystal angles here. For example, if you choose side pump cylindrical rod and tab models, you need fill in the different boxes such as your pump power, flow tube and reflector radius and distances, refractive indices and diode characteristics and their distribution around the rod. At the moment, you can watch your laser mode window, your pump attraction in crystal and array tracing from diodes toward crystal, flow tube and reflectors. By clicking on button Show Pump Profile, you will be able to watch absorbed power density in X and Y axis and along Z axis. This capability let you adjust your optimal needing attraction by changing pump configuration in laser cavity. Now we have a window which shows array tracing of diode pump beam from the fast axis perpendicular to rod axis. Here is another somewhere you can optimize your pumping and converge the entire pump light in crystal by adjusting the distances and a proper laser diode or even changing rod diameter and other parameters.